The problem name is find the duplicate number. We are given an array of integer nums containing n plus 1 integers, where each integer is in range of 1 to n inclusive. Inclusive means n is also included. Exclusive means we should remove n. So there is only one repeated number in nums. Return this repeated number. Only one repeated number will be there. So we must return that repeated number. You must solve the problem without modifying the array and uses only constant extra space. So we are given this in the example 1. The given array is 1 3 4 2 2. Here 2 2, you can see 2 is repeated 2 times, and in the example 2 we can see 3 is repeated 2 times, so we return 3. So all the integers in nums appear only once except one integer which appears 2 or more times. So only one integer it can appear 2 or more number of times. So suppose if this point is not there, we can sort the array and find the duplicates, and that is one case. It will modify the array because sorting modifies the array. And another case is we can use a hash set or hash map. But in hash map we can do the frequency. We can find the frequency of each element in this array, and we should return the number which is the frequency. We should return the number whose frequency is 2 or more. And in the hash set approach, we should while traversing we should check whether the number is already in the nums in the hash set or not. If it is in the hash set, we will be returning that repeated number. If it is not in the hash set, we should be returning the we should continue our loop to see whether the next elements are repeating. So without modifying the array and without using constant extra space, we can use a brute force approach, like using two for loops. Here you can see we can use two for loops and check whether the nums of I is equal to nums of j. That is, we check whether the current index I is containing on the other side. That is on the other part, is it containing, that we check, and if it is on the other side, we will be returning that nums of I. Like here in this example, suppose here it is I. Suppose there is here it is I, and we check in the j part whether this I is repeating on the jth on this side. If this one is repeated on the other side, we will be returning this one. So in that way, this two for loops is going to solve this problem, but this is of time complexity n square. So in the constraints we can see that n is of 10 power 5, so this will fail and we get the time limit exceeded. Here we can see that it is a time limit exceeded. So the optimized approach is using Floyd cycle detection algorithm. In this algorithm, where we detect the cycle and use two pointers to again search the starting point of the cycle. So let us see this optimized approach, Floyd cycle detection algorithm. Here we will use we start from 0th index, and here we can see that 0th element is containing 1. So next we move to 1th index. From here these elements are acting as now indexes. let us assume like that, so that we can understand this algorithm. From 0 you can move to 1. So now it is moved to 1. So from 1 you can go to 3. So you can go to 3. From 3 you can go to 2. So you move to 2. From 2 you can go to 4. So now you move to 4. From 4 you can go to 2. So from 4 you again go to 2. So we will use slow pointer and fast pointer. These are not actually pointers, but these are variables. I will so these are just variables. These are not pointers. So slow will jump one. Slow will jump one jump. So slow will make one jump, and fast will make two jumps in one step. Here, slow and fast are pointing at the same index initially. So first slow will be moving one jump. So slow will make one jump and fast will make two jumps ahead. So fast will make two jumps here, one jump for this and one jump like this. So slow is moved two steps. Fast is moved two steps. Slow is moved one step. Now again, slow will jump. Slow will make one jump. Fast will make two jumps. One here, one here. So fast will be moved here. Now slow will make one jump and fast will make two jumps. One jump like this and another jump to the same point. Now slow will make one jump and fast again makes two jumps. One here and another one here. So slow and fast are made at fourth index. Now to find the star, so we found that there exists a cycle. So cycle is detected when slow and fast meet at the same point. Now what we need to do is I will take another variables which is s1 and s2. So now the s2 is pointing at fast. So where the s is equal to f, so where sf is pointed here, right? So I will be pointing s2 is equal to 4. Now s1 will be starting from 0. So from 0 you again, so s1 will jump one jump. So s1 will make one jump and s2 will make single jump. Now s2 will make single jump. So now s1 is pointing, so let me use different color. S1 is pointing here, S2 will be pointing here. Okay, now S1 will make one jump and S2 is also make one jump in one iteration. So now S1 will jump first and S2 next. Next S1 will jump first and S2 will make another jump. S1 will make one jump and S2 gonna make another jump. Now S1 and S2 are pointing at the most repeated element, that is 2. So we should return this uh, starting of the cycle, starting point of the cycle. So why this S1 and S2 is how this S1 and S2 will be pointing to the repeated element, that will be given by this formula. So here the slow pointer or a slow variable is making a distance of, or else it is a covering distance of, suppose here S and F are met. Suppose let us think like this, and here the S1 will cover this much distance, right? L1 this much distance, and it will cover like this. So S will cover this much L1 plus L2 distance, and fast pointer will make two jumps, right? Like this, like this, like this. So this will cover more distance, right? So there may be a chance. So the fast pointer covers more distance here only, right? Like in this, suppose S1 is coming like this, but S1 is coming like this, and here fast pointer may cover more cycles before coming to here. So suppose this is of a cycle distance C. Let us think that is, suppose this is of a cycle distance C. So the fast pointer will cover n into C, and it is also covering L1 plus distance of L2, and extra it is covering of n into C cycle length, where n is the number of times it is covered in this loop, and C is the cycle distance. So this cycle distance is C. So this much of distance it is covering. So in order to make a slow is equal to fast, so slow need to cover two times the distance of slow. In order to make slow is equal to fast, it is slow should cover two times extra, right? Because fast is jumping two jumps, and slow is jumping one jump. Slow is making one jump, fast is making two jumps. So in order to make slow is equal to fast, it is also it should be multiplied by 2, so that we can make this slow is equal to fast. So slow will cover L1 plus L2 distance, and fast will cover L1 plus L2 and some cycles in order to in order to make slow is equal to fast. So uh, I have kept a slow distance here and fast distance here, and in order to make slow is equal to fast, I have multiplied it by 2. So now when we expand it, we get 2 into L1 plus 2 into L2 is equal to L1 plus L2 plus NC, right? And when L1 is bring it to left side, L1 minus L2 is equal to NC. So one L1 is removed and one L2 is removed. Now L1 plus L2 is equal to NC. Now when we move L2 to the right side, now L1 need to cover NC minus L2. L1 need to cover NC minus L2 distance, where NC minus L2 will be again this much distance, and also it needs to cover some loops, where NC is it needs to cover some loops, and it should remove this distance. Means when you do minus L2, it will get this much distance, where minus L2 will give the this much x distance. So in that way we should be moving like this and like this, and it will cover some cycles, and L1 will and L1 L2 will be pointing here. So the time complexity for this approach will be of O of n, and space complexity we use only 4 variables. It is of time complexity O of n. Now let us write this code. So this is the brute force approach. I'll copy it here and comment it. Now what we have used slow pointer. Slow pointer will be starting from 0, and fast is also starting from 0. And here um, while slow is not is equal to fast. Suppose slow and fast here. Suppose slow, first initially, suppose there is only one element, and it is there won't be one element, right? Here let us see the constraints. There is only one element. Then what will be the repeating number? Nums dot length will be of n plus 1. Okay, it will be of at least two numbers. Okay, now what should be the condition here? For suppose I will assume initially I will run till the while loop. I will run infinite loop, and when slow is equal to fast, then only I will break. And here what I need to do is I will slow will jump, slow will make one jump, so nums of slow, and fast is going to make two jumps. So for that fast, so this will be one jump, and inside nums of I num nums of fast, this will make two jumps, so that this will meet some at some point. So what this will make to meet, so when slow and fast become equal, we just break it. So we break the loop here. Okay, now I will take another variables, s1 s1 is equal to s1 will be starting from 0, and s2 will be starting from fast, or else slow, or or slow, anything we can take, because they are pointing to the same index. Now this is also same like we used before while loop. We will be returning when s1 is equal to s2, we will be returning that index, and s1 will make one jump. S1 will make one jump, s2 will make one jump. So now s2 will make one jump, s1 will make one jump, and when both s1 is equal to s2, we just return s1, and if it is not there, we will be returning -1. So it is definitely will be there, and here the execution will end, and so will be starting from 0, and fast is starting from 0, and slow will make one jump, and fast is going to make two jumps. This will make one jump, and one more jump is making this one. When slow is equal to fast, we'll break out of the loop. That means we have found the equal parts, and we again start s1 is equal to 0, s2 is equal to fast, as is said here. S1 is equal to 0, s2 is equal to fast. Here s2 will be 4. Now this both s1 and s2 will make single jumps, so it will make single jumps, and instead of returning here, we can return outside of the loop also. We will break from there, and I will be returning s1. So in this way, the program is going to end at the starting point of the loop, or else cycle. So let us run this. Now this is working with example 1. Let us see this example 2. Now this is also working with example 2. Now let us submit this code. So this is working with all test cases. Now the time complexity will be O of n and space complexity is O of 1 because we have used only two variables, and time complexity because this is going to take order of n approach, and this is also going to take O of n, and that's it. And this is the proof for this, where L1 is equal to NC minus L2.